Good morning, children. Children, we have completed the first two units of class 12th chemistry, that is the solid state and solutions. Now I am going to take up the third unit of class 12th chemistry syllabus, that is electrochemistry. Children, this unit is very important as far as the board examination is concerned. Not only the board examination, you are going to get varieties of questions under this chapter in the competitive examinations also, like a NEET examination, JEE examination, as well as CET examinations. Children, electrochemistry is the branch of chemistry which deals with the study of conversion of electrical energy into chemical energy and vice versa. In other words, electrochemistry is the branch of chemistry which deals with the study of production of electricity from the energy which is released during the spontaneous chemical reaction and the use of electrical energy to bring about non-spontaneous chemical reactions. Children, in simple, this chapter deals about chemical effects of electric current and electrical effect of chemical reaction. With this introduction, let me take up the next unit, that is electrochemistry. Children, in fact, we are going to study the electrochemistry under three parts. Let me write. Number one, electrolytic cell. Electrolytic cell. Second one, electrochemical cell, which is also called galvanic cell. We will take up later. Third one, conductance of cell. Conductance of cell. Children, electrolytic cell is a device which converts electrical energy into chemical energy. I repeat, electrolytic cell is a device which converts electrical energy into chemical energy, whereas electrochemical cell, which is just opposite to electrolytic cell, wherein it converts chemical energy into electrical energy. I repeat, electrochemical cell is a device which converts chemical energy into electrical energy, whereas the third one, children, is very important, that is conductance of cell. Children, in the third part, we are going to deal with electrical aspects of electrolytic cell and electrochemical cell. I mean, what is their resistance and resistivity, conductance and conductivity, and how to improve the conductance or conductivity, and those are the electrical aspects you are going to study under the third part, that is conductance of cell. Children, without wasting the time, let me take up the first one. What is that? Electrolytic cell. Children, as I said, electrolytic cell is a device which converts electrical energy into chemical energy. In electrolytic cell, the external source of voltage is used to bring about the chemical reaction. Very simple, children. In this case of electrolytic cell, the external source of voltage is used to bring about the chemical reaction. Let me introduce a term for you, that is electrolytes. What is that? Electrolytes. Children, electrolytes are the substances which conduct electricity when dissolved in any polar solvent like water. In other words, the substances which conduct electricity when dissolved in water are called electrolytes. For example, children, I can quote sodium chloride, potassium chloride, etc. Now let me introduce one more term for you, that is electrolysis. Electrolysis. Children, if I split this term into two parts, electrolysis, that means the process of dissociation or decomposition of an electrolyte when electric current is passed through either its aqueous solution or molten state is called electrolysis. Simple, the process of decomposition or dissociation of an electrolyte by passing electric current is called electrolysis. Condition is that the electrolyte should be dissolved in polar solvent or it should be in the molten state, and that is what you call this electrolysis. Children, electrolysis is carried out in a compartment or a cell which is called electrolytic cell. What is that? Electrolytic cell. Nothing but a compartment or a cell wherein electrolysis is carried out. Hope you got it. Children, let me take up a particular kind of electrolytic cell, then you will understand what exactly happens in the electrolytic cell. Children, in order to understand the functioning of the electrolytic cell, let me take up simplest electrolytic cell, that is a copper electrolytic cell. Children, copper electrolytic cell consists of a vessel made up of either glass or any material which is a bad conductor of electricity, and the vessel is called electrolytic tank or electrolytic cell. In this electrolytic tank, I will take aqueous copper sulfate solution. You know that copper sulfate being an electrolyte undergo dissociation to form respective cation and anion. Let me write, look at here, copper sulfate in water undergo dissociation to form Cu2 plus ions and SO4 minus ions. Children, after some time a dynamic equilibrium is established in the solution between copper sulfate and the ions which are formed in the solution. Children, the ions which are formed in the solution exhibit random independent motion. Though they have random independent motion, it is not possible to isolate independent cation or anion from the solution. But remember, the solution always remains electrically neutral. Children, now I am going to insert two copper strips which are called electrodes into the electrolytic tank containing copper sulfate solution. Now I connect these two electrodes to an external battery with the help of metallic wires. Children, the negative terminal of the battery pushes the electron towards the electrode, and this electrode develops negative potential and is called cathode. Hope you are getting that. Similarly, the positive terminal of the battery, pulls the electrons from the electrode, and thereby it develops positive potential, and that will act as anode. Hope you are getting that. Anode is a positive electrode, whereas cathode is a negative electrode. In other words, the electrode which is connected to positive terminal of the battery is called anode, whereas the electrode which is connected to negative terminal of the battery is called cathode. Children, when the electric current is passed through these electrolytic solutions, the cations and anions will not have random motion, but they would acquire directional nature of motion. That means the cations which are positively charged, they migrate or move towards the negatively charged cathode, whereas the negatively charged anions will migrate towards the positively charged anode. Children, this movement of ions in the electrolytic solution is called electrolytic conduction or ionic conduction and constitutes the flow of current through the electrolytic solution. Children, let me write what exactly happens at cathode and anode. Children, at the cathode, the Cu2 plus ion gains or take up electrons from the copper electrode and get reduced to copper, later deposit on the surface of the cathode. That means, look at here, Cu2 plus ions takes up 2 electrons from the copper electrode to form copper. Children, gain of electrons is nothing but reduction. That means reduction takes place at cathode. I'll write here reduction. Then what happens at anode? Look at here. At anode, children, copper is converted into copper 2 plus ions by losing the electrons. Look at here. Copper is getting converted into copper 2 plus ions by losing 2 electrons. And you know the loss of electrons is called oxidation. That means oxidation takes place at anode. Children, during this phenomenon, the electrical energy which is stored in the battery keeps on decreasing as the electrical energy is getting converted into chemical energy. And that is what the definition you learnt under electrolytic cell is, a device where electrical energy is converted into chemical energy. Hope you understand this. Let me go for the next topic. Children, let me take up the next topic, that is quantitative aspects of electrolytic cell, which is very important for the examination. Children, in the year 1834, a great scientist called Michael Faraday studied the quantitative aspects of electrolysis and electrolytic cell. On the basis of his studies, he has formulated 2 laws known as Faraday's law of electrolysis. Let me put on the board. Number 1, Faraday's first law of electrolysis. Second one, Faraday's second law of electrolysis. Let me take up the first one. What is that? Faraday's first law of electrolysis, and then I'll take up the Faraday's second law of electrolysis. Remember, I said both the laws are very important for the board examination, and you are going to get 1 mark question on this Faraday in the competitive examinations also. Children, let me take up the first law of electrolysis proposed by Faraday, called Faraday's first law of electrolysis, which is very important for the examination. Children, Faraday has constructed different types of electrolytic cells in which he has placed electrodes which are connected to the battery and an ammeter. Ammeter is to measure the electric current. Children, in order to measure the time, he has used stopwatch. In other words, you can say that to know how long the electric current is passed through the electrolytic cell, he has used stopwatch. He has observed that the mass of the substance which is electrolyzed in the electrolytic cell is directly proportional to the current if time is constant. Let me put that in the terms of mathematical expression. M is directly proportional to I if a time is a constant. Children, that means the more the electric current is passed, more will be the mass of substance electrolyzed. For example, by passing 1 ampere of current, if 5 grams of substance is electrolyzed, then there will be 10 grams of substance electrolyzed by passing 2 amperes of electric current, provided time should be kept constant. Children, he has also noticed that the mass of the substance electrolyzed in the electrolytic cell is also directly proportional to time if current is kept constant. Let me put that in terms of mathematical expression. M is directly proportional to T if I is constant. Children, that means with increasing time, more amount of substance is electrolyzed. For example, if 1 gram of substance is electrolyzed in 10 minutes, then there will be 2 grams of substance electrolyzed in 20 minutes, provided electric current should be kept constant. Children, if both I and T are not constant, instead they are variables, then the mass of the substance electrolyzed in the electrolytic cell is directly proportional to current and time. Now, if I want to put that in terms of mathematical expression, M is directly proportional to I and T if both current and time are variables. Children, I and T nothing but electric current and time, and we know the expression Q is equal to I into T, is it not? I into T. So what I do, M is directly proportional to Q. Children, Michael Faraday has removed the proportionality sign by introducing a constant called electrochemical constant, that is M is equal to Z into Q, where Z is electrochemical constant. What is this? Electrochemical constant. Remember, if Q is equal to 1 coulomb, now what will happen? Look at here, M is equal to Z. M is equal to Z. Children, based on his observations, Faraday has proposed the first law of electrolysis, which is called Faraday's First Law of Electrolysis, which states that the amount of substance deposited or liberated at an electrode is directly proportional to the quantity of electricity supplied or passed. In other words, during the electrolysis, the mass of the substance discharged at an electrode is directly proportional to the quantity of electricity passed. This is very, very important for the examination. Now, let me go for the second law of electrolysis, which is called Faraday's second law of electrolysis. Children, after the first law of electrolysis, Faraday has connected a number of electrolytic cells in a series, and he has passed same quantity of electric current for same time through all the electrolytic cell. He has observed that the mass of the substance which is electrolyzed in each cell of the series is directly proportional to the equivalent weights. In other words, when the current and time remain same, the mass of the substance electrolyzed in each of the cell in the series is directly proportional to the equivalent weights. Let me put that in the form of mathematical expression. M is directly proportional to E, provided I and T are same. Children, where E is nothing but equivalent weight and M is nothing but mass of the substance electrolyzed. In that case, look at here, m1 upon e1 is equal to m2 upon e2 is equal to m3 upon e3 is equal to m4 upon e4. Children, I can write, if you take only 2, then look at here, m1 upon e1 is equal to m2 upon e2, or m1 upon m2 is equal to e1 upon e2. Children, based on his observation, Faraday, as stated, is the second law of electrolysis named as Faraday's second law of electrolysis, which states that when same amount of electricity is passed through different electrolytes connected in a series, the masses of the substance discharged at the electrode are directly proportional to their equivalent masses or the weights. Children, just now you have learnt about the laws of electrolysis proposed by Faraday. Let us learn the unit of Faraday. You know that the charge on each electron is equal to 1.602 into 10 to the power of minus 19 coulombs. Let me write on the board. The charge on each electron is equal to 1.602 into 10 to the power of minus 19 coulombs. Children, we also know that number of electrons in 1 mole, what is that? Avogadro number, 6.022 into 10 to the power of 23. Therefore, the charge on 1 mole of electrons is equal to 1.602 into 10 to the power of minus 19 into 6.022 into 10 to the power of 23. If you simplify this, you are going to get 96,485 coulombs per mole, or can simplify that 96,500 coulombs per mole. Children, the charge on 1 mole of electrons is called Faraday in the honor of Michael Faraday. I repeat again, the charge on 1 mole of electrons is called Faraday. In that case, look at here, 1 Faraday is equal to 96,500 coulombs. This you need to remember. Children, the charge on n moles of electrons can be given by the expression, look at here, Q is equal to n into F. This is required for finding the number of Faradays required for the reduction of certain kind of ions that I am going to take it now itself. Children, let me take up the first numerical on Faraday. The production of 1 mole of sodium or 23 grams of sodium by the reduction of sodium ions requires 1 mole of electrons. Find out amount of charge required for the reduction of 1 mole of sodium ions. Children, you know that 1 mole of sodium ions are reduced by 1 mole of electrons to form 1 mole of sodium or 23 grams of sodium. Now you know the expression Q is equal to N into F. N is nothing but number of moles of electrons used. Is 1 mole of electrons are used, and Faraday value you know that 96,500 coulombs. That means 96,500 coulombs or 1 Faraday. Children, the amount of charge required for the reduction of 1 mole of sodium ions into sodium requires 1 Faraday or 96,500 coulombs. Let me go for the second one. Let me go for the second numerical. Find out the amount of charge required for the reduction of 1 mole of Cu2 plus ions and 1 mole of Al3 plus ion. Let me take the first one, that is 1 mole of Cu2 plus ions. Look at here, children, for 1 mole of Cu2 plus ion reduction, you need 2 moles of electrons. That means you know this, Q is equal to N into F. So how many moles of electrons are required? 2 moles. 2 into Faraday. What is Faraday value? 96,500 coulombs. That is equal to 193,000 coulombs. Otherwise 2 Faraday. You can say that 1,93,000 coulombs are required for the reduction of 1 mole of copper ions into copper. Otherwise 2 Faraday of charge required. Hope you got it. Now let me go for the second one. Is 1 mole of aluminium ions. Children, look at here. For the reduction of 1 mole of aluminium ions, you require 3 moles of electrons. In that case, Q is equal to N into F. So number of moles of electrons is equal to how much? Yeah, 3 into Faraday value, you know that 96,500 coulombs. We are going to get 2,89,500 coulombs. Or you can say 3 Faraday of charges are required for the reduction of 1 mole of aluminium ions into aluminium. Hope you got it. So this kind of numerical can be asked for 1 mark in the competitive examination.